Hi everyone, today I'm going to show you my latest update of the EC and pH controller. As you can see, I've updated the GUI a bit, changed the fonts and colours, added loads of other functions. I'll go through what I've added and how it works, a bit about the electronics, the code, general overall discussion of the device itself. To start with, you can see it's displaying the EC and pH, the current temperature, the water level, and the date time. The water level is currently at 0, but if I put my hand in front of the sensor, there we go. Let's take it away. And it's using an ultrasonic sensor. It's got a display timeout. We'll adjust that quickly. Just get a pen. Set that to 5 minutes so it doesn't noise again. Where to start? Going back to the home page. We shall start from the one below, that being the graphs. It's probably better that I restart the device quickly, just because I have this in a demo mode where I can show you the accuracy of the graphs. So let me just press reset on the Mega. And we're going to the graphs. So we're just going to change it to EC mode, because I have the EC mode showing exactly 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 I believe. This is just some mock data in there. Of course the end product would have real sensor data being shown in the graphs, which is already written in the code. I merely just commented it out and placed some dummy data in the arrays. I just want to show you how it correlates exactly between the positions. It automatically updates the side scaling exactly, the x-axis and the y-axis. They line up perfectly. It will show a maximum of 12 readings. I think I had a little jump there, I could go over to the code. But as you can see, it's going up and up and up. I did a major jump right there just to get it to go right up to the top with the arrays I had available. As you can see there, the graph works quite nicely. What else do we have after the graphs? We have max mins, being this tab just below. I don't need to show you the graph going to the end, but you could see it if you wish. Once it reaches the 12th position, the graph will shuffle back one position and add the newest position to the end. So basically the current readings will go left one and the newest data will be in the end, so just like you'd expect with any other graph. So it's always showing the latest 12 readings. So now it's got to the end of the dummy readings. The next reading is going to be a real sensor reading. There we go. So that's the EC. That'd be right down to 0.45. Of course I've got it going up to 10, so you can't really see that accuracy. Perhaps the pH will show a bit different. There we go. Where it's the actual value scaled across the display area, it does show quite a good visual representation of minor changes in sensor values, such as we're seeing here changes of 0.4 to 0.3. So that's the graphs. After that, as I said, we have max mins. Oh, a little bug of mine that I haven't noticed. I shall go over that. So as we can see, the C and the M are overlapping there, so that needs addressing. That shall be sorted. basically I just need a bit of code to push them left and right based on their width. Either way, that is the max and mins. Nice and simple. You can actually see that the end's gone over to the end side there. That will stay there because that's not a refresh error, so I will have to fix that. Next we have our page to save and load configurations. So once we've set all the values for the EC, the pH, temperature, water levels, our dosing amounts, the light on time, Wi-Fi, ignoring warnings, other settings in the settings themselves, including these preset names, you can save them to one of 5 different modes, and of course you can rename these. So if I click on this, of course I made these all. This isn't some library or code that I've copied of someone else. This is all my own code. And you can see it's got a little cursor. I've just written preset Ed. My name's Ed, by the way. I'll just get my pen out. Now, with these displays, I'm not using a calibration chip. I've had to manually calibrate the display via software, so it could be a little bit out, so I'm just going to do it a bit above. There we go. It is, it's just a bit above. But as you can see, we can delete characters. We can go uppercase or lowercase. If I put a capital E, I'm having to look for my phone to see where my pen is. This is rather awkward. I'm quite happy I've just said, really. Of course, you've got your numbers at the top, you've got a dot, you've got an underscore. I could have had a space there, but it was just a bit weird. I didn't have enough space itself on my keyboard to write the word space, and a blank block to represent a space character was a bit misleading. So I just stuck with an underscore, so there's no need to press it. So that's our keyboard. You can have up to 10 characters max, as you saw earlier on. And of course you can click save. We'll just click save. That would save it to a given EEPROM position. Out of these total 5 presets, I think we have about 90 bytes left of the EEPROM, because there's quite a lot of data. I'll go on later on explaining why there's so much data being stored. Anyway, that's the save and load configurations with the keyboard. After that, we have our page for our pH. So here you set the minimum tolerance and the maximum, the maximum set point, the minimum set point, and the tolerance. Where if the sensor is in between the minimum and the maximum, let's say the sensor's at 6.25, no adjusting would take place. Else if the pH is lower than 6, then you'd obviously need to do some pH up. And if the pH is greater than the maximum, you'd need to do some pH down. You can set a tolerance, so that, say if I set this to, I don't know, 1. Oh, that's going down. Do I have it set? I think the maximum I have it set for is probably a whole of 1. Anyway, let's say I set to 0.2. Oh. Okay. Anyway, let's say it's set to 0.2. That means the sensor would then have to go to 6.7 to before adjusting would take place, and it would have to go to below 5.8. The tolerance is really just there as a marginal gap, just to increase the dead zone where no adjusting would take place. The same is to be said for the EC, minus the exception of the doses actually using up or down, well, depending on what nutrients you use. You could define what doses doing what nutrients if you have some kind of special nutrients that adjust the EC. Either way though, you set the minimum, the maximum, the tolerance. Again, if the sensor is between the two, nothing will happen. But in this case, it will only adjust when it goes below the minimum. So in that case, if the EC is below the minimum, it will adjust it back up to in between the two. Again, you can set your tolerance, and you can set it as a minus on this one. So you could say that when you go below 1.2, take it up to 1.4. I just have it set to 0 because I'm quite happy with it going up to 1.6. Originally, I did have an inlet pump so that it could actually drain and refill the tank to adjust the EC. Oh yeah, I'll reset the MCU so the display time's gone back to normal because I haven't pressed save. Pardon me. Again, the same for the temperature. In this case, the same as we said for the EC. If the temperature goes below the minimum, it would turn on a relay. That's one of our relays. I believe one of the relays is on right now. I think that's actually the one for the... That's probably the one for the light, I think. Yes, it is. We'll get to that. But it'll turn on the relays for a fan or a heater, whatever kind of heater you have in there. Water heater, air heater. And it would, or even a fan. And it would obviously turn it on until it gets back to the maximum, plus or minus the tolerance. Nice and simple. Admittedly, those ones don't really need a maximum minimum, but I just put it in there anyway. Surprise, surprise, we've got the same for the water. So if the water goes below the minimum, then it will fill it up to the maximum, plus or minus tolerance. Of course, these are nice and responsive. I suppose I haven't really showed you, but if you hold it down for so long, it will start incrementing in 0.1, so there we go, we've got to our maximum now. It's not going to go any higher than 99. I'm quite happy with that though. It does like to do that, a bit of a ghost press. It's because I'm using, not only am I not using a calibration chip for the X and Y, I'm not even using a touch chip, this display driver. So I'd have to turn off the LED, we'll show you in a minute, but the display driver does have special outputs for you to use a touch chip that costs, I think, about £5, that's far more accurate. And it does, I think that chip itself also calibrates the display as well. So you get far more accuracy on your touch and you don't get these ghost bounces. We're having to use interrupters here to actually monitor the touches, so it's not the best. Anyway, that's the water level page. Something a bit more interesting now. Now we have our doser page. We have 4 doses on this device. You can change the modes. I have it for EC, this is just the default, pH plus, pH minus. I only ever really need to do pH minus, so I'd quite happily have that on EC mode, so that we could have whatever, some part A, some part B, and some PK, some boost, risotonic, whatever you're using on that one. You can of course prime the pumps. I do believe I don't have the doses calibrated at this point because I've kind of set it to the default settings. So in our conglomerate of parts over here we have a doser. I have a battery here and some cables, because these are 5 volt doses, well 6 volt doses, they run at 5 volts quite happily, but obviously the Arduino and the USB I'm powering off certainly isn't enough to run all of this and doser and some relays. So we've got some 5 volt regulators there with a couple of capacitors. They're all MOSFETs, don't get mixed up. That's a 5 volt regulator that's not actually being used at the moment. That one actually failed. It's putting out 7.6 volts and it fried my old relay module. It does not work anymore. It just shorts out. Anyway, I'm drifting off here, so let me just connect up the power. Just chuck over this battery, wedge these under, rather precariously placed. Not the best. Oh, see, one popped out. 1 second, sorry, I should have done this preemptively. I forgot I hadn't had them in place. Trust this to be a pain. That's that cable in. Let me just put the other one in. I should really have some crocodile clips. You think I would? Arg. Right, that LED is on. That was a pain. I'm quite sorry. And now I've covered up our doser back there. Anywho, if I was to press prime right now, we'd probably just hear the doser vibrate and shimmy along the table. Let's have a look. Yes. Why is that happening? Because I've set the calibration speed lower than the inertia to overcome the motor. So we're going to have to go into the settings quickly. We're going to have to kind of skip somewhere. So we're going to settings quickly. Again, we didn't save our settings, so that reset. Put that back to 5 minutes. Well, I wanted to disable the LED because it's messing with my camera. That's better. We can leave the tone on. I'll go back to explain this in a minute, so I'm just going to go straight to calibrating our doses. This is the percent of the speed the dose is running at. I think 40% was enough, it was literally just a bit off. I was experimenting what was the minimum speed I could set them at before they turn. Now, my software is rather crude in the sense that these doses have no encoders built into them. You could, I suppose, put one into it in many different ways. It's even got a see-through case, so you could even use an infrared sensor to detect the turns, but I don't have anything like that at the moment. So my doses run merely on the basis of being calibrated for 1 milliliter per second. This can be achieved through the PMW and using a potentiometer on the motor itself, and even if you must, you can adjust the interval in the software for extra calibration, but really the potentiometer on its own should be enough to get it to do 1 revolution per second, or adjusting the PMW. Certainly both combined would be enough. You shouldn't need to go into the software and do any more. Now if I press prime again, 40 is still too low. We'll put it up a bit more. Again, this is set to the default values. I should adjust these to say start at 50%. Let's just adjust that. This. Okay. What did we say? 50% before we start out? I prefer it goes faster than slower. Camera. It went up in the 10 times. Forgot it does that. Again, I prefer it's higher. This small button, well, that is responsive. You saw that it was being odd and incrementing. That's the way that the display interrupter works. Obviously the interrupter has to call a function to determine the press and such, so it's not the quickest of interrupters. It's the default interrupter of the library, but again, I've seen interrupters that should only be 1 line of code, and this is more like 20 lines of code. So not the best interrupter. Again, you can get a chip to do all this for you, so we really are emulating for this with a chip that can only do 1 process at a time, so it's not the most responsive. £5 could fix that problem. Let's just set it at 54.5, we're quite happy with that. We're going to be able to turn the motor now. And if I press prime now, there we go. And of course, you can make it go much faster and potentially a little bit slower to the point where it would do just, I think I've got it to do about half a rotation a second at the minimum. Anyway, that's how you prime your pumps. You can obviously adjust the EC. Then go up nice and fast. The pages are very responsive because they've been coded in a very clever way. Really, I should show you an example of how that's working, but if you think this whole page is being displayed, you're quite wrong. This outer section only ever gets refreshed when you press a button. This is the content area, to which this page gets completely refreshed when you press one of these buttons. And then once it's committed, whatever doesn't need to be displayed again will not be, such as these doses will not be displayed again, these buttons will not be displayed again. The only thing that's really changing, even that EC and EC stays the same, these need to be updated, the milliliters, these two buttons and these milliliters, because this is an addressable display, a memory addressable display. I can literally target an individual pixel. But what you must do is you must draw a rectangle perfectly over your value. That's how you refresh it, drawing a rectangle over the value. If I was sure I set one of the pages to an example mode for you, but obviously haven't. If I was to set that to an orange rectangle, you would see that it starts perfectly at the beginning and perfectly end, because I'm using the function getCursorX, which means that my software knows exactly where the cursor is finished once it's printed this and this and this and this, and I have a function, a previous state function, so it says if dose of 1 milliliters does not equal previous dose of 1 milliliters, draw a rectangle from the start of cursor X to the end of cursor X, and then display the value. So that only happens each time the value has changed. So therefore, at the moment, the display is not even refreshing at all. This is just a static image, and that's why it's so responsive, because at the moment all it's having to do is just refresh that one little value, minimal pixels. And if you're thinking, well, that's still pretty slow, I've put in a 200 millisecond delay between increments, because if you had the default, it'd have just got to 1,000 immediately, well, not immediately, but far too fast for you even to count your eyes. It's very, very fast at refreshing. I just find that any less than 200 millisecond delay, press the button once and it's gone up 5 or 10. And even then, as you've seen, it can do a little ghost press, but that's just to do with the interrupter software emulation. Right, so that's doses. Change the modes, set the values, prime them, and we've got our light control tab. Obviously light on, light off, on, off, auto, or on, auto, off rather. And as I said, I believe that was the light wheeler, so if I press off, there's the camera over there, there we go. And if I press auto, it's not that time of night, I'll show you, it's 6:21, I could have showed you the RTC on the homepage, but there's no point going back to there. Now, it was actually incredibly hard to write a function. Have you ever owned a digital timer where you set it to auto and plugged it in and it hasn't actually turned it on? You've had to press on and then go into auto mode, because I certainly have. And I'm talking from a reputable store. Let's say I've gone into my local hardware store and paid about £15 for a digital timer. And it wouldn't be able to detect if it needs to start the light automatically on boot in auto mode. To which I had to write a piece of software to say, if the time is greater than X or less than X, turn the light on. And it isn't just that many lines, that's for sure. It's about, I think it's about 30 lines of code to be able to work out if to turn the light on or not, because it's so complex. What the light on time could be greater than or less than the light off time, to which obviously the light on hours could be equal to, less than, or greater than the light on light off hours. The minutes obviously can't match, but then obviously you could have it on starting at one day and then coming off the next day, to which you then need to work out. It sounds like it should be easy, but it's not. It's one of those things you think, I'll do that. And then you're sat there for the next 3 hours thinking, how the hell can this actually be done? And I managed to do it, but my god, did it annoy me. So yes, if you set it to auto and then turn off the device and turn it back on, if the light should be on, it would turn the light on. That's the best way to describe it. After that, what do we have? We have a Wi-Fi page, yeah. Don't worry, I'm going to get round to all the electronics soon enough. Now, it's probably better that I just leave that for a little while. It's going to take 1 minute to display some values. If I go over to my PC, Oh, look, we've already got a response. Server response okay. There's just a bit of debugging stuff I have there. Server response okay, so I need to explain that to you in a second. Let me just get out my web page. Oh, it was over here. If I just go on this, I'm gonna have to log into. It's nothing major. It's just something I bashed together, a bit of HTML. And the time currently is what, about 5:24? And that's a minute behind. Oh no, that's 7:23. 17:23, 18:23. Oh right, yeah, I haven't adjusted time on there. Well, that doesn't surprise me. That does not surprise me at all. Basically my software forgot to count for daylight savings in this. I must have set that up last summer. Oh well, that's just a +1 and -1 to the server time. But as you can see, I had this running on earlier on as well, so this is what our latest two values here, 23 and 24. Again, the time's an hour ahead, so I'd need to go into my PHP and adjust that. But what is nice to say is that it will show the latest 20 values, and just like the array, it will shuffle them up one. So effectively, we have a for loop saying, in this case, for int I is less than 20, get array position. Well, you start at 0, and array position 0 equals array position 1. And then you go way up to the end of the array -1, so that's taken every row above the row and put it into the row below, and then the final row equals the current reading. So in that sense, you shuffle all your values up every time once it reaches the maximum. Obviously, if that was, if I cleared all that data, it would have started at 0. The PHP code is quite clever. It will detect if the product ID exists. Yes, there is a product ID for each one. PHEC A001. That could be hexadecimal. You could go up very high. If the ID doesn't exist in the database, it will create 20 rows for that device, and obviously set the product ID for all those 20 rows, and that's it to start with. Well, in the background it sets a few other details I'm not going to tell you. But once it's created the database with 20 rows for the user, it has a row ID on the ESP, to which it starts at 0, and it sends it to the database and says, does your row ID match mine, or is it less than mine? So in the sense that if I send a row ID of 1 and this has 20, it would ignore it. But if I send a row ID of 1 and this has 0, it would insert that into row 1, and then it would increment the row ID on the PHP code, and then in the ESP, and the ESP would set in row 2, so alright, I'll insert that into row 2, and then once it gets to 20, again the shuffling starts happening. Like I said, you can just view the latest, or you can view the history. I do have another code on the other page. I'm surprised I didn't put this in there, where you can view by hour. It's a doddle of a code. What do? You split the date time and detect if the current hour does not equal the previous hour. And then that will show it by hour, quite simply. And then you just need another table to insert it by hour, let's say 24 hours. And you can also click a graph. Anyway, that's networking. I suppose I should explain how the networking works. It sends the data over one of the hardware serial lines to the ESP. This ESP chip actually didn't have the serial 0 pinned out, so I had to solder a couple of cables in there. But essentially it's just an ESP 12F or a 12E, but it's definitely an 8266 12 or E, 12, sorry. It's got 4 meg of memory, your standard ESP essentially. So the data is sent over serial to the ESP, and the ESP then sends it to the server, or essentially it sends it to a PHP handling script. The PHP handling script puts it in the database. I think I've blabbed on enough about that. Yep, so we have some warnings. I've ignored them later on because it is rather annoying. They're all out of range. I keep putting my hand over this ultrasonic sensor, so that's why you're seeing the water level changing so often. It's not being silly. If I... Oh, I forgot. I need to put bounce on that a bit more. Anyway. So, also we're getting a beeper code. That's using a external driven buzzer. So you do need to, I hope I got that one right. You need to provide it the correct frequencies for it to work. And you can do a whole range of monotones, or every monotone. If I turn the RGB LED on, you'd see it flashing red in sequence with the RGB LED. What I must say is those, really I should be using an external micro pit to do these two. Oh look, we've got a alert out. This is a bit early, I don't think we'll be seeing this. No, we don't want to continue. I wish I had time to explain that better. I'll probably have to... Oh, I forgot that bug's happening. Yeah, I forgot to... what happens when it says no. I need to adjust that later on. So now we're going to see that it's adjusting EC. As you could see there, I haven't got any other doses in, it would be running other ones. As you could see with the warning message that came up, that was basically saying that the dosing's about to start happening. And you probably noticed that it actually told us how much out of range the EC was. Well, yes it did. It said it was 53.6%, I believe it said, out of range. And what was happening there? Well, basically it was saying from our EC and pH set points, get the current pH value and work out how much out of range the current sensor value is compared to the set point, and then do the same for the EC. And then let's say that the EC is out of range by 20% and the pH is out of range by 50%. Well, it's going to adjust the pH, isn't it? Because that one needs to be adjusted the most. You can go into the menu, I've already thought about this, and you can set a variable called max tries. So in the sense that if the pH is out of range consistently, after so many max tries, let's say, I don't know, what have I got set to? I think I've got it set to 5. It's going to be on one of the other pages. We need to go over and explain all these. Calibrate doses, adjustment interval. No, it's not those ones. Machine learning. Ooh, we need to get to that. Yes, it does have machine learning. Max tries, pH swap interval, 3 tries. Yep, there we go. So essentially, when we've done the pH adjustment for 3 times in a row, and the EC is out of range, let's say this was out of range, like I said, by 50%, and it's done it 3 times in a row over our adjustment interval, to which you should, let's say, have it set for, realistically, let's say you're adjusting it every 6 hours, because you want it allowed time for it to mix. The longer you have that interval, the better. I can't express that more. Anyway, let's say you have the adjustment interval set to 6 hours. After 3 increments over 18 hours, it's done just the pH, and the EC is still out of range by X amount. It's then going to say, oh well, we've reached our max tries, the EC percentage is greater than 0, let's do the EC this time. And it's going to do whatever, obviously, it's going to adjust the EC so much. Again, that was set in the dose page. So, I'm quite glad that showed up, really. I must have set the value a bit lower. Because I remember I have got some of this set in demo mode, so you could see some of the functions running. So now let's start talking about the settings page. Like I said, I will get around to electronics in a minute, do not worry. So we have display time. I don't think that needs to be explained any further. Disable LED. Well, we know what that does. That disables the RGB LED. If I had that enabled, we'd see it flashing with the warning. Oh, I didn't display that. So yeah, the warning really could do with a micro pit, because when that buzzer is going, that's obviously taken up a lot of system time. And because of that, you get lag when pressing the buttons. Whilst it's beeping, you really get no response at all. There is a gap between it, because I have coded it so it does do it. As I said, without the tone library, it uses a for loop to go through it. But nonetheless, no, I could really say that you should use a cheapest chip, micro pick, and just send a simple command saying alarm 1, alarm 2, or beep. You know, couldn't be simpler. Send that over I2C or serial, however you wish. I will probably get around to that. I do not have a microchip. You could probably use something like a 16U, but even then that's overpowered. We just need, realistically, we need 3 PMW pins to drive the RGB LED and 1 PMW pin for the buzzer. I call it a buzzer, it's a passive speaker. Is it passive? The one that needs to be externally driven. Ooh, I should really make sure about these phrases first. Sorry if I may confuse you there. Anyway, then we have disable tone, yep, so that disable autofill, essentially that's linked to the water, so if you have disable autofill enabled, of course it's disabled first, so if disable is enabled, it's not going to do any water adjustment. We have autofill interval, so you can set that as low as 1, I believe. Oh look, it came on. 2 days I have it set as minimum. Yeah. Alright, whatever. Might have to go through that and adjust that code so it can go down to 1 day minimum. So every other day it would fill the tank, or every next day it would fill the tank if it needed. I must have thought to myself that 2 days was good enough. I suppose it probably is. No tank should drain within 2 days. Anywho, it's intriguing that that LED is coming on, so... Yep, so I just put my hand over the sensor and it came off. Oh, so that did work. That works lovely. Very good. Graph interval. As I said, I've got that set to a demo mode of 10 seconds. Just literally statically written there. But you can actually set that in the settings. 1 minute, 2 minute, 3 minute. I think that can go way up to like 180 minutes or something like that. And again, it will start adjusting in tens. Everything, if you hold down any button for longer than 30 seconds, it will start going up in 10 times its increment value. We could reset the device. So what's that going to do? That is going to delete every setting from the EEPROM and reboot the device, and then rewrite the EEPROM with all the default values. Because my code works in the sense that you don't need to populate the EEPROM first. All I do is say load EEPROM block 0, and if EEPROM block 0 equals the EEPROM key, let's say my EEPROM key equals 101, so if the EEPROM block equals 101, then load all the settings, but if it doesn't, save all the settings. That's essentially all it needs to do. So when it boots, if there's, by default an EEPROM block would equal 0 or 255, I've found that some come with either. But let's say you've bought a brand new Mega, it would either have 0 or 255 populated in all the EEPROM blocks, so you can guarantee that it wouldn't equal 101. So when it first boots, if the EEPROM block does not equal 101, it will save all the settings. So therefore, auto-populating EEPROM. Very nicely done. So let's press this, we're going to get another warning interval. There we go, I quite like these. Again, I had to make all these myself, pain in the ass. Do you really want to delete all the save settings? The device will reset if you continue. Well, of course we're going to press no. Back to normal. Right, next page. No, we've already been over this a bit, haven't we? Calibrate our doses. Yep. Adjustment interval. I mentioned this briefly already. That is the check. Oh, my phone was just warning me that it's going to make a new file. Anyway, the adjustment interval is the time it will take before adjusting with the doses again. 30 minutes. You'd be in real trouble if you left it at 30 minutes. I couldn't think of any tank that would actually take effect in just 30 minutes. You know, it's going to take literally hours for the value to settle, especially with pH. So in my opinion, I would have that set to hours. I'd hope that I have adjusted this to go from minutes to hours. Let's have a look. Ooh, from 30 minutes to 1 hour to then, is it going to say hours? Oh, isn't that nice? 2 hours. Is it going to 1.5? Oh, it's even better. That's nice, isn't it? Disable pH EC adjusting. Well, I don't think I need to disable say what that is. That's going to obviously disable the adjustment of VC and pH. Now machine learning. Ooh, now we're getting somewhere. I need to explain what that does. I should get to that very soon. Disable temperature control. Well, we know what that's going to do. Disable the temperature control for the relay there. Clear Wi-Fi credentials. That's going to send a command over the serial to the ESP to literally say delete all the saved Wi-Fi details that you have stored. So it's effectively like brand new if you wanted to give it to someone else or whatever. I don't know, if you're just paranoid. Calibrate water sensor. Well, I need to explain this, don't I? So this is an ultrasonic sensor, and it was quite a simple process. When you press yes, it's going to take the current reading. So let's say in this sense I had it literally set to my ceiling, which is about 1.5 meters away. I don't know why I'm pointing the camera up there, idiot. Anyway, it's going to take the current reading, which is going to be its maximum reading. So let's say you've got this place in your tank and it's facing at the bottom of the tank and the tank is completely empty. Let's say it takes a reading of 30 centimeters being at the bottom of the tank. Once you've filled it up, it's then going to, well, sorry I said that wrong. You have make sure your tank is completely empty and you press yes, and it will take the reading being the bottom of the tank. Then in normal operation, the ultrasonic sensor would take a reading and subtract that from what is I call the zero reading in this reading here. So if the zero reading is 30 centimeters and then you fill your tank up, it's going to take a reading of what, 5 centimeters. 5 minus 30 would be 25 centimeters of water in the tank. Nice and simple. I don't need to press yes because it's not going to say anything more. It would just in the background take a reading of the ultrasonic sensor, and I have it literally just pointing here, there, everywhere. And that's calibrate water temperature. Temperature and F. I've got more than enough space. I should update that. Well, I might not actually. That is quite a long word, Fahrenheit. Yeah, we might not fit it in there. Anyway, temperature and F means temperature in Fahrenheit. Click that. It'll check in Fahrenheit. Set the date time. Click that, and it would I should show you really. Obviously, set all these. See, set the day of the week. Today's Saturday, obviously. Set the date. Obviously, set the time. Starts in seconds. No, I made sure this was super quick because this potentially shows how quick the refresh page can be, or the refresh this page can be. And of course, once you hold it down for so long, we're going to start going up at the minutes. Now I wanted to make sure you could do a whole 60 seconds before the minutes changed, so you could adjust the finer things. It's still going to take forever even at this speed to adjust the time, so heaven forbid if you have to do it. But as you see, it does actually start at the current value, so it does save you some time. Of course we're going to click cancel because I had it set to the right time. Water in inches, need I even say what that's going to do? It's obviously going to display the water in inches. And that's all our settings done, isn't it? Well, that's all the GUI covered. Back to the home page. Now we need to start discussing electronics. Fun. Now I should say that I am no electronic expert. I haven't even got a course in electronics. I'm a computer programmer. I have a degree in computer programming, and I'm currently doing a master's in applied computing. And electronics is just, you know, in the background. It has to be done to do the software. So I end up doing it myself most of the time. So what do we have here? We have an RA8875 display, 800 by 480. You're going to come down and cry now. Now my doggie's going to come down. My trusty companion. Murphy, no. Sorry. Sorry. Can't ignore your dog though. Anyway, so Murphy's put me off. He's a Bichon Frise. He's a good boy. Aren't you? You're a good boy. There's the Yorkie up there somewhere. Sorry. Yeah, I love my dogs. Anyway, back to it. Murphy, sorry. I'll play with you in a minute, I promise. I'm almost done. Right, let's bash this out. we've got the RA8875 display. You can get these in many versions. I've got the 5-inch version. As I said, I haven't got the digital calibration chip, or touch chip, whatever you want to call it. I'm just using an Adafruit RA8875 touch, it's called a display driver. As I said earlier on, it does have outputs for you to go directly to a display chip, being those Y plus, Y minus, X minus, X plus. That's weird they did in that order, but they did. And essentially it's just got a beefy chip on there to do process all that memory. Imagine how many, well what is 800 times 480? That's already a big number. And then each one of those is a 565 colour representation, which is, it's hexadecimal, 1, 2, 3, 4, 5, 4, 8, 12, 16, 20. I think it's about, yes, let's say it's 24 bits per colour, per pixel, so 800 times 480 times 24. That's the amount of data required to display that whole display. That is a lot for a poor little Arduino. So that's why it has to send this over SPI to this, where it then buffers everything in the memory, and then I can get the luxury of just saying, well, right, well, let's just update this one little pixel once you've displayed the page, because as you've seen, what's a slow page to load? The menus. As you can see, it's loading it bit by bit by bit by bit. But then once it's loaded, as I said, then it's all it has to do is just refresh whatever I'm doing. So I call that the initial commit time. The initial commit time can be quite slow, but then once you're in the page, blazingly fast. So thank God it's memory addressable. And that's the display covered. We obviously have our speaker here. I shouldn't really need to cover that much. Externally driven. I'm using special code that I have access to that isn't that doesn't use any timers or libraries. It's literally just pure on the code using the mills function and a while loop. Couldn't be nicer, because we can't use tone library because it would interfere with the pins we're using. We're using a lot of pins, so we have to use software to do that tone. But that's not a problem. I managed to do it. We've got a Osram Octo RGB LED. Essentially that's just an RGB LED that I soldered to a board. Bit ghetto, but you know it works. It's actually a really nice LED. There's loads of colours, but nothing like my RGB strip. But that's a special internally driven RGB strip. Next after that we have our RTC chip. What is it? It's a DS3231. I'd be happy if I get that right. Let's just go over to the code. 3231. Well, it is. Well, I'm getting to know them more, aren't I? And then we've got a 5-volt regulator with a couple of capacitors. Should be. Now we're getting to the nitty gritty stuff. Well, let me just to cover the last easy things. We have our ultrasonic sensor. Now, I've just bought one of the waterproof versions. It hasn't showed up yet, but you can get these completely waterproof. They're about the size of a penny, a 2p rather. Let's say the size of a large coin. Obviously much thicker though. And they're completely waterproof, because our temperature sensor is waterproof, our EC and pH are obviously waterproof, but this isn't. You drop this in your tank, you're in trouble. But I've just bought a waterproof one, so that excludes that problem, and also where it's such high humidity that would corrode pretty quickly. So don't just go out and get a normal HCSR04 ultrasonic sensor. Get the waterproof one. £5, cheapest chips. Even cheaper than this one, funny enough. So that's the water level sensor covered, being an ultrasonic sensor. We've got our ESP here. Put my finger over there. That's better. So essentially it's just an ESP. See that light flash then? That was the server response saying that it... I'll cover that in a second. Anyway, ESP826 E or F version. You can just get a bare bones one and solder the pins itself. This is just it's called a ESP202 board, and it's basically all the pins jumped out. So that's all the pins jumped out there. The LED will flash each time it gets a packet back from the server saying that it's got a successful response. So that's quite useful. And of course, that response is then sent over serial to the Mega, where the Mega then knows that it's connected. And I'm going to add a little Wi-Fi LED in the corner to display the status. Hey MF, we'll go out soon. I can unplug this battery now because it's in the way. Now we've got these. Now this is just a Chinese pH sensor. Just literally Google Arduino pH sensor. I've put it in the comments. They're like £10. And this is the name for it is a 100i, but you can now get a 100i V3. It literally doesn't have any more name than that. If you just Google, I'll put it in the comments. It's an Arduino EC meter. It's from America. Really expensive. What, £70? Maybe $100? Or in between the two. And it's literally just what I picked. I have nothing to say that it's better than the rest. I know that DFrobot do one for the same price. So don't be committed to get one of these. I literally just took it out of its casing because it was too cumbersome. Now the final thing of this is how these two are controlled. You're probably noticing that that's coming on and off. This had an LED on there too, but it fell off. But what they're doing is there's a 4-second gap between the two. That's come on, then 4 seconds later this will come on, and that will come on. Now it's not as simple as that by any means. I need to explain why you need to do this. Both of these cannot come on at the same time. Here's our sensors. Couldn't be in closer proximity, literally in the same cup. Turning one on and then one on the other time isn't good enough on its own. You can't just take one sensor reading and then another sensor reading and think they won't fit. It's not the readings that are interfering, it's the power and earth lines. What's happening is, both of these work on conductivity. There is a voltage being sent down there, and it's working out the resistance, or the conductivity, respectively. The EC sensor is conductivity, this is resistance. Or that's how these sensors work in essentially anyway. If I have an earth from this connected whilst this is reading, well, some of that voltage is going to go down this earth, and this value is going to be off. If I have the power cable from this in there, active, whilst this is taking a reading, where it's going to get a different reading as well, because it's going to get some of this in voltage induced. Now, if you're thinking, well, that's only going to be putting voltage out to the sensor whilst I'm taking a reading. No, these sensors are always active. They're not solid state, but let's think of them like that, that there's always voltage and power supplied to each probe, and that you're essentially just taking the reading whenever you request it, because they're always ready for your request. So there is always power and earth being supplied to each one of these probes, and that will affect either of them, the power of the earth on its own. So you must isolate the earth, and of course if you're isolating the earth, then just generally need to isolate the power. You can't have something with no earth but power connected. That would just kill your electronics. So how do you do that? Well, just some cheap as chips transistors. If I can get my camera down here. What's making... oh, it's the light from the RTC chip. If I try and put my thumb over it. We don't really need to... but I'd love to get a good picture of it. Come on camera, do your best. Well, you can see it down there. These two components right next to the red wire, right in the centre of the display. That is two cheap NPN transistors with a resistor in between the two. I forget the exact value of the resistor. It looks like it's 220. And what's happening is I have the power, and the power is connected to the first one with 5 volts coming into the transistor and the 5 volts coming out the transistor, with the gate obviously connected to a digital pin. So when I activate my digital pin to the gate, it turns on the transistor. This thing is like a little mini relay switch. It's a transistor, just a little mini switch transistor circuit. When I apply power to the gate, it's opening it up for the power to travel through to turn on the sensor. The resistor goes from that same gate pin where the digital wire is connected, to the gate pin. The resistor connects the gate pin of 2 transistors together, where the one digital pin can then activate both of them. The left one is used for the earth reading. You can kind of see the earth wire there. And then you have the earth wire connected to the other side, so it's basically inverted, the transistor circuit. So that when I activate the gate for the right hand transistor, the left transistor is also activated via the current travelling through the resistor. So therefore we are switching the power and earth at the same time. Exactly the same circuit, hiding back there. You see now you can see 4 of them. You see those 2 closest to us? Exactly the same for the EC. Switching the earth and power with 2 transistors. There, that's a good picture. We can almost even count the colours there. Red, black, black, brown, red. Or is it brown, red, black, black? Whatever one's in between 200 and 1000. So yeah, 2 NPN transistors. Probably should be using a PNP and an NPN transistor, which I do have in my drawer, so I should be using the correct ones. But again, I'm no expert in electronics, so I literally just kind of googled one quick thing, see what would work with components in my drawer, and tried it, and it works perfectly fine. Like I said, there's a 4-second gap between the 2, and not only that, there's also a 400 millisecond gap between activating these transistors and then taking the reading, because what's referred to as warm-up time, you want the current to be able to charge properly through these circuits. But to be honest, they both have capacitors and other components in them, so they probably will be holding their current for that 4 seconds anywho, or at least most of it, unless they're cheap capacitors, but they're not. They're aluminium ceramic ones. No, sorry, just aluminium ceramic, no such thing. A mixture, that is. Well, again, I don't know that. Now we have the circuit to control our MOSFETs, which in turn controls our doses, the exact speed of our doses, as you saw. Essentially, it's just a standard MOSFET. These ones rate up to 60 volts. They have a few resistors connected to them. You can see that quite nicely there. And a Zener diode as a kickback diode, so that you don't fry your circuit if the motor is turning. I mean, that's not really a problem for these doses, because as soon as you stop the voltage, they're going to stop because of the amount of inertia, let's say. It is resistance, but it's just funny using resistance in an electrical term and a physical term. But because the way it's a parasitic pump, obviously it takes a lot of inertia to turn the motor, and therefore as soon as I stop the voltage, it's going to stop. But if you had it at a really high speed or a bigger doser, you may get some voltage coming back whilst the motor's turning. As you know, if you turn a motor, it creates power. That power would come down, and it'd be a lot higher than the power inputted, albeit at a different amperage. But let's say you could get like 100 volt signal, not signal's the wrong word, but 100 volts could come back down the doser into our circuit here, and it would fry everything. So what happens is the Zener diode then puts it back through the earth, and essentially it just keeps looping around the motor till the power is dissipated. Of course, you lose power for each time you do whatever with it, but albeit through heat and motion and whatever else we're doing. So that's the circuit to control the doses, which is essentially just a MOSFET, a Zener diode, 2 resistors, a couple little bits of proto wire, and that switches the earth side. I should say that the power is always connected to the doser, and this actually switches the earth. Very efficiently done. That's how it should be done. They don't even get hot, nowhere near hot. So what? That's discussing the way the doses are controlled, the way that the sensors are controlled via 2 NPN transistors connected via a single resistor, requiring 1 digital pin to activate both transistors. These MOSFETs work via a PMW pin. You could just use a digital pin, but then you'd have no variance in speed control. As I said, I want them to do exactly a milliliter a second. as close to it as I can get. As I said, this is just some cheap Chinese pH sensor. Half it's not even written in English. Nobody really even knows what half the pins do. And this is the EC sensor. I think I even have a link up on my page. That is what it looked like originally. They refer to it as the 1003 V1. And it's if I just put an Arduino EC sensor and go in images, you can see it's the first one there on Amazon. I believe it was charging like $100 for it, which is extortion really. Can't see the price straight away, but I know it was 95. Anyway, there was another person selling it for 100. We'll go back to the list now. We should have a whole table of readings. We do. Going all the way back for this video. You've missed one packet over the time, but that's acceptable. Time is now 1 minute past there. As I said, this is 1 minute behind because it's a 1 minute interval. I need to adjust that PHP code. Of course, it's displaying the maximum, the minimums, the current temperatures, the device ID, water levels, well, that's the readings anyway, and the time of insertion on the server. Not that there's much to it. You can just use the original tutorial for how to connect the display driver, an RGB LEDs and RGB LED. The speaker is just one wire. The RTC clock is your standard tutorial. The motor control via MOSFETs, well, you might need to Google that a bit. I suppose that's a circuit I will need to make. What circuit diagram I need to make is at least the MOSFETs, and if needs be the transistor circuit. Again, it's just 2 transistors and a resistor. I suppose you need to know exactly which way around the wires go, so we'll make both of those circuits for the transistors and the MOSFETs. If you need me to make the power regulator circuit, I can. It's just an input, an output and a ground with 2 capacitors inverted from each other to give it some high capacitance, fair enough. And yeah, that is it. We've definitely gone over the whole GUI. Nice and responsive, nice and responsive, updated. You know, really nice. All I need to do is sort out that bug with the max mins, because in fact I think I know what's wrong with the max mins. It was showing a double decimal point for the water level. Yeah, water level is not meant to be in decimal points. It's meant to be an integer. It is an integer in the code, so it shouldn't be displayed as a float. So obviously I need to say (0) on there, and then that would have been fine, wouldn't it? Because that's more than wide enough. So all I need to do in the code is just change that to not show the decimal point, and that would take a whole probably 5 seconds. I will discuss the machine learning very quickly. What is the machine learning? Well, it's very clever. Basically what it does is it works with an accuracy of 0.1. So what does that mean? Well, to put it simply, let's just work off the pH. The pH has got a scale from 0 to 14. So for an accuracy of 0.1, you need to times that by 10. So it has an array of 140 for each preset for the pH down, and another array of 140 for the pH up, and another array for the EC being 60, because we're going from a value of 0 to 6 max for the EC. And each time it doses the EC or pH, let's say in this case it's dosing the pH, it would take the current value and store it in that array. So if the current value is 5 for the pH and it's dosing, it will save that value in the array very cleverly. It does a calculation to actually, based on the current value minus precision and other such things. It's literally like a few lines of code, no for loops or anything like that. It would take that value and place it exactly in the array, respective of to the value within 0.1. So if we've got a reading of 5, that would go in block 5, funny enough. But if it's 5.5 5, it would still stay in block 5, or if it's 5.1, then it would go in the next block. 5.2 would go in the next block, so it's got a precision of 0.1. So anyway, let's say it's dosed to pH and the reading is 5. It's stored it in that array block, and on the next dosing interval, somewhere down the line, let's say you've had the interval set for 3 hours. After 3 hours, it would then dose again, to which it will record the adjusted value. So if it started at 5 and 3 hours later the EC is 6, it would say, okay, the value's gone up a whole 1. Let's save that to the block. Then however many days or hours or minutes later it took to get back to that original value, it can then go into the EEPROM and say blah blah blah, 5 times something equals block 10. Is there a value in block 10? Oh yes, there was. Well, what did you equal? When I did the dosing, I was 5 and it went up to 6 at the value of 5. To which it can then say, oh, okay, if I want to get to a value of 6 or 7, let's say, I need to double my dosing. This is just really simple math. It's a lot more to it than this. But basically it takes the current reading and then the next reading, works out the difference between the two, and then adjusts the dosing amount in mils respectively. So if it dosed, and this is within 0.1 precision, there's hundreds and hundreds, well not hundreds and hundreds, there's 160 blocks. So if it gets to, if it saved the value at 5.1, and then later down the line the value equals 5.1, it can say, if you're at 5.1, I know for a fact that it's going to adjust the dosing, so it's going to adjust the reading by 1. And if you need to get to the target set point, which is a whole 2 away, let's double the dosing. Or if the target is 0.5 away, let's half the dosing. Do you understand what I'm saying? So it's taking the current reading, the next reading, working out how much it's adjusted it, for each reading with a precision of 0.1, and then later down the line it can load that recording, say it adjusted it by this much, work out the current gap between the sensor and the set point, and then multiply the dosing accordingly, be it up or down. So let's say the multiplier comes out at 0.1 and the value is 5, then obviously that would be 0.5. It's a bit weird maths, how maths works there, but that's how maths works. Anyway, so machine learning will make sure that the amount of milliliters adjusted is exactly right, as long as it's been ran long enough for it to save all these values. Like I said, they're saved in EEPROM, as long as you click save each time before you turn off the device. After it's been running realistically for a whole month, it would have a value in probably every one of those array blocks, essentially, or at least the ones that are always being used, and it would get a very accurate picture of exactly how much to adjust how much to dose the pH up or down or EC to get to the exact target point required based on the current reading. I can tell you that took a long time to write, and I have got example codes that I separated from this code. Obviously I tested it separately and fed it hundreds of different scenarios to make sure it actually does work. And it does. So it's not just a static set my pH at 5 milliliters and let's say that we only need to dose, well, let's say that the current pH reading is 5.999. Well, I said that wrong. Let's say the EC is 5.99 because we've got a precision of 0.2. Not 0.2, precision of 2 on our floats. This is a different precision here, you're going to get confused. And the gap is only 0.1, so we're at 5.99 and we want to get to 6. Instead of dosing 5 mils, which would take us over our value, it'd work out exactly how much to do it, and it'd probably be, let's say, 0.001 of a milliliter or something silly. And that's obviously worked out in milliseconds, so it can actually do it. It would say, let's run for 100 milliseconds instead of 5,000 milliseconds. And that's the machine learning. So it's got machine learning to work out exactly how much to adjust, but it needs to build up a history to do that. Obviously, machine learning works on a large data set and clever calculations. That's definitely it. I'm sorry that I took so long to record this video. In a sense, this has took like an hour and 20 minutes, and I probably have forgot something. And I've had to record it on my phone because, well, this isn't on my PC, is it? I've had to show you the display doing all the things. And as you can see, I've redesigned the electronics so it's far more smaller to get a scale of how big that is. You know, that's your average pen. It's probably 2¼ inches, 2¼ inches wide, tall, by about 8 inches long. And then we've got our 2 sensor boards, a knockoff Mega, ESP, the ultrasonic sensor, our R2C clock, the 3231, the display driver, RGB LED, speaker, 4 MOSFETs, 4 MOSFETs over there, 4 transistors there, 2 for each sensor, a voltage regulator, that one I'm not actually using at the moment, I've got another one over the back here, an 8-channel relay to which you only need 4 channels, 1 for temperature control, 1 for light control, 1 for the outlet pump, and 1 for the inlet pump if you want that code included. I found that it was fast annoying to wire up plumb up all those pipes to get it to drain the stuff, and anti-siphon valves, this, that and the other. It just gets so annoying. However, if you did get a inline pump that can go in reverse, then things get a bit more interesting. We can use a motor driving chip to actually reverse the motor and use it to fill and drain the tank. Oh, that'd be nice. But they're rather expensive, hence why I don't have one. And that's that. That's definitely everything covered. That's all the electronics. That's the software. Well, I say the software. Like I said, I think there's about 9,000 lines of code to that. So I'm not going to cover all that. And then there's about 400 lines to the ESP code. And then loads of PHP code, SQL code, HTML code, JavaScript, this, that and the other. Really, I'm sure only most of you are interested in the Arduino code. You probably don't even want the ESP stuff. And it would make it a lot easier. Like I said, if you do want access to the software, please send me an email or a message, and I can sort something out. But it is not to be redistributed, sold, or harvested for parts of the code to be used in other things. It is literally just to be used for this one device for yourself. If you do want to do something where you want to sell it, obviously we'd have to work out a deal, but that's not out of the question by any means. I'd happily sell this to a company for an end product. Yeah, that would